So this is novel. It's great to be back. I've been at every conj since the first one in my neck of the woods in Raleigh-Durham, North Carolina. And I'm going to be talking today about this little database project that I and some other people have been working on in Clojure called Datomic. You may have heard about Datomic. It has a set of characteristics that preserve the things that I like about SQL and add some things that address limitations. In particular, I want to build data of record systems, typically. And so I want the ACID transactions that I'm used to having from SQL, and I also want to have a powerful query language. It doesn't have to be SQL per se, but something logic-based. But at the same time, there are things that I don't like about SQL, and that's being stuck in tables. And so it's nice to be able to model sparse data or hierarchical data, and to be able to make more granular statements about schema and have that kind of flexibility. In addition, what else is there to say? What other words are on there? Indelible, that's a good one. So I also want to have a database that remembers. So not just knows what's true right now, but knows what was true 10 minutes ago and 2 hours ago. And once you have an indelible system, you also have a straightforward path to chronology, right? To understanding what happened and what followed happened. Now, these are the words that we've been using to talk about Datomic for the last 5+ years. But it came to my attention today that these words are no longer inverted pyramid compliant. So apparently I have to update my spiel to match the new inverted pyramid of programming problems. And so, luckily I know how to zoom in on things, so I can make graphics big enough that you can read them. So the red arrows point at where, I mean, it's not surprising, right, that Datomic and Clojure are philosophically aligned, right, designed by the same person. But the arrows are just sort of connecting the dots between some of the things that Rich said this morning and what Datomic is about. So Datomic stands against place-oriented programming, right? We don't have places. We have values, the value of the database, and we have managed references. Datomic gives you help with concurrency, admittedly, the kind of help that databases have always given, which is ACID transactions. And it also deals with the problem of parochialism, right? Datomic has you working with open, associative collections and having those things have good names, right? Taking advantage of strong names. So this is all directly overlapping with things that Rich said this morning that were motivations for why he built Clojure. He wanted to address these problems in the middle and not necessarily address the problems down at the bottom because they're too trivial to put a lot of effort into. And we know that the problems at the top are super hard, right? Misconception in the domain. So we are not going to necessarily address those directly with our tools, at least yet. But at least we can make some headway against these problems in the middle. So that's pretty cool. And the information model in Datomic has been unchanged since its release. There have been new capabilities operationally, but the information model has stood up well because it was generic and general. I'm not going to talk any more about it today because there are some things that are not so great. If you wanted to sit down and build an app with a database. Datomic was originally designed to run on the cloud. It was originally designed to run on the AWS cloud. And there's a lot of value propositions and promises that the cloud makes that are still pretty hard to get to when you're thinking systemically. Not just thinking about this box that represents my database process, or this box that represents one web app process, or this box that represents some other application. And some of those things include a pricing model that's sort of pay as you go, and the agility that comes with that. Another thing that you really want is to have scaling that's elastic, right? So the ability to say that your system can flex up and flex down in responses to things that are happening in the world or in responses to things that you say. That's sort of the promise of virtualization. And so this isn't necessarily awesome. I mean, Datomic's information model does nothing to make any of these things awesome. Let me put it that way. Right? The information model is cool, but it doesn't give you any of these operational characteristics automatically. Meanwhile, users have changed in what they want since we started building Datomic. And there's a big move to more ephemeral processing. There's a big move to processing happening on weaker, less reliable hardware and software. There's a move towards microservices and things running in containers. And all of this sort of advocates for having a model for interacting with your database that's very lightweight on your side, right? That doesn't have you sort of participating in, say, Datomic's peer model. So that's a challenge. And when you sit down to put this together in AWS, there's a lot of pieces. And these pieces are simpler than a monolith. I said simple once, right? There's some kind of drinking game I know some people are playing, so that was the first time. These pieces are simpler than a monolith, and some of the individual pieces are pretty simple and some are not. But in any case, putting all of them together still requires a lot of knowledge. A lot of knowledge about the semantics that you want from your system, and a lot of knowledge about the operational characteristics that you want for your system. And regardless of what your database is, some of this stuff is still going to just be on you. So what can we do? How do we make Clojure an awesome environment for building things on AWS? And in particular, in the subject of this talk, how do we make Datomic easy and a great choice on AWS for Clojure programmers? So if you're running on AWS, you're writing code in Clojure, to have Datomic be a tool that fits your hand when it can. And so what we've been working on for the last couple of years is thinking through the possibilities there. One possibility, of course, would be to have a service. And a service would be fantastic because it would take all of those complicated pieces that you have to fit together that I showed on that previous slide, and it would put those into behind a dotted line called magic, where somebody else does it for you. So, that would be super great. And obviously, it would deliver on the sort of operational promises of the cloud, because really, all the operational promises become the provider's problem. So that would be cool. But in talking to our users, we came to realize that there were some pressure points mitigating against service. So not everything is all about service. When you're talking about your data tier, you don't want to read the SLA, you want to write the SLA. Does that make sense? Right? You don't want to consume an SLA from somebody else and you're sort of stuck with it. You want to be able to say, here's what I want to be able to deliver. Also, it's been a value proposition of Datomic from day one that you can write code that lives near your data. And one way to do that is with Datomic's peer model, if you're familiar with it. It's not the only way, but that's one way to do it. And code that lives near your data is challenging in a service because now you're asking the service provider to run your code. And that's also, typically going to be a problem. And then maybe the worst thing, and this is kind of a Goldilocks problem, is what you really want to have at a service is your hands are completely off of it, you don't have any worries, but if you ever are worried, you can grab the control stick and put your hands back on it and be in control of it. And so I have a simple visual diagram to show you what that looks like. All right? So at the top left, that's the cockpit of the Concorde, I believe. And so when you're ready to put your hands on the controls, having never had your hands on the controls before, right, when something bad happens, it's like, okay, yesterday I've never touched the controls. Today something bad happened, I want to put my hands on the controls. And you look at those controls for the first time, that's not going to be a good experience. On the other hand, Johnny Cab, in the bottom here, if you remember the movie, right, Johnny Cab drives Arnold Schwarzenegger around, but he doesn't actually give any control. And the kind of frustration you have with that kind of hands-off in a service is pretty evident when Arnold rips the little robot guy's body apart. So we don't want to be there either. So the question is, and this question is going to have trade-offs in it. And so as I give this talk, I think you should think about what the trade-offs are. But the question is, what could we do to sort of stand in between there and have our cake and eat it too, to some degree? And so what we've done, what we're working on right now, is a new Datomic offering called Datomic Cloud on the AWS Marketplace. And what this is going to give you, we hope, is a sweet spot in between those two extremes. So there's going to be automation for putting together all the pieces that you need to run the database in the cloud. You're going to press a button, and then you're going to come back, and you're going to have a database. So it's going to be like turning on a table in DynamoDB. So that aspect is going to be service-like. But as a marketplace, first off, how many people have run a marketplace application in AWS? Anybody? A few. So the way the marketplace works is you go and click through a thing and say, yes, I'm willing to run this, and then you get to launch a special AMI or as AWS, it turns out they pronounce it AMI, which I didn't know. But we had to talk to the marketplace people, and they keep saying AMI, and we keep not knowing what they're saying. It's their word, though, so I'll try to say AMI for the rest of this talk. So you run an AMI, and then this just shows up on your Amazon bill. Right? It just shows up as a line item on your Amazon bill. You've got DynamoDB, S3, and now you would have Datomic. It just shows up on your regular Amazon bill. So what's that going to look like? And I actually am going to come down where I can see these slides so that I remember all the points. The primary entry point for this is a thing called the solo topology. So the solo topology is an instance of Datomic Cloud that is suitable for development, suitable for your test system, suitable for CI. Our CI system uses one of these. Suitable for personal projects. It delivers the full programming model of Datomic, and it integrates AWS security, integrates monitoring. It's triply redundant durability. So everything in Datomic Cloud is stored in Dynamo and in S3 and on EFS. And there is a Bastion server for dev access. So you can actually use this. It's secure. It's running inside of a created VPC, which you have to get your application inside of, or VPC peer or whatever, right? All the serious grown-up go-to-production stuff. But for development, there's a Bastion server that you can SSH onto inside your client API call. So you can configure the client to say, use SSH locally and SOX proxy onto the Bastion and get on that way. So it's a Datomic instance that's available over the web for dev purposes if you want it to be. And the AWS line item for this, if you leave it up running 24/7, is going to be about $1 a day. And the programming model is clients. So about a year ago, we started doing Datomic clients. I gave a talk at last Conj about ETL jobs using Datomic clients. And clients obviously are something that's going to need to happen if this thing is going to run over there in the cloud and your application is going to run somewhere else. These clients are async and sync. So the bottom model is async using core.async channels and transducers and all the sort of goodness when you want to have your high level of control. And then on top of that, there is a sync API. And importantly, this still delivers the Datomic information model completely. So when you call getDB on the connection, you get a value of the database. And you can query and operate 6 times against that value of the database and know that you're still working against the same baseline. And so this is what that looks like. The solo topology is a storage resources, which we'll talk about more in a minute. And then there's a primary compute CloudFormation stack. This is a great chance to learn a ton of icons if you want to take an AWS exam. The little green bricks are a CloudFormation stack. There is an auto-scaling group that keeps up the solo node, which is a tiny AWS instance. There's another auto-scaling group which keeps up the Bastion if you want one. Application clients live inside the VPC. So your programs that in production live inside the VPC, or if you're a super fancy networking person, they VPC peer or whatever you want to do. And then for convenience of dev, you can SSH SOX in from the outside. That's what solo looks like. And I've just got a couple of pictures of some of the AWS stuff that's automated. Solo has a CloudFormation dashboard. When I was talking about this in the Datomic class yesterday, a couple of experienced AWS hands were flabbergasted that you can programmatically create AWS dashboards now. So if you didn't know that, if you're an AWS person, that's only true in the last, several months. But this is super cool. So when you stand it up, it automatically creates the monitoring stuff for you. This is a picture of the outputs from the CloudFormation template. And all important Diet Mountain Dew break. How many of you can read all the line items there? My objective is not to show you what those are. The important point I'm trying to make here is that what has to happen behind the scenes to fit this stuff together is a lot of little pieces, a lot of little fiddly bits. And all of this stuff is designed to incorporate what we believe to be best practices for running Datomic in the cloud. So every line on there is something that in today's world you would have to get right if you wanted to automate deploying to AWS. And in this world, you press a button and it's done. Logging is integrated. the logging. So this is me doing a search on the log to see a report of all the transactions that have ever run. You can do log searches against individual instances if you're troubleshooting, or you can do log searching across the entire autoscaling group. In the case of Solo, that's not going to be very different because Solo is only running one instance. Everything is tagged with AWS tags. So all the sysops people are going to be super happy when they go in here and try to understand what's happened. They can do a tag search and say, show me all the Datomic resources for this particular system, or show me all the Datomic resources for all systems, or whatever else you want to do using AWS's tagging and query language. And then integrated security. So it's been a long-standing desire for people to have encryption at rest with Datomic. And an obstacle to that when you're running Datomic as it exists today is Datomic as it exists today is on-premise software. It's architected for the cloud, but people are running it on-premise at least half of the time. People are running it backed by Oracle. People are running it backed by Cassandra. People are running it backed by MySQL, Postgres, whatever. And what that means is there is no standard way to say, hey, we're going to do key management. Right? If we were going to make encryption at rest in the existing Datomic stuff, it would have to be some sort of integration point that you would have to meet. And it would have documentation, and it would be a pain in the butt, and it would have different flavors and so on and so forth. The great thing about integration with AWS is choices are made for you. So all this is now just taken care of. You have encryption at rest. Everything is encrypted using keys that are managed by Amazon's key management service. The clients connect and they authenticate via the AWS HMAC algorithm. So if you trust communicating with S3 or Dynamo today, then you should trust this. It's the same algorithm that AWS uses. Everything is isolated by VPC, and there's a fine-grained permission model that is based on IAM. This is actually super cool, and so I'll just throw this out as a puzzle for those of you who, I know we're not supposed to do puzzles, we're supposed to solve problems, but I will throw this out for you as a puzzle. Normally, it's not possible to extend IAM's permission model because it's kind of parochial to AWS, right? They have IAM permissions for their services, but they don't have an extension point so that you can make IAM permissions for something that you're making. But we came up with, and it's kind of a hack, but we came up with a cool trick that lets us actually integrate directly with IAM. So you can specify IAM permissions to do fine-grained permissions. And one of the fine-grained permissions in the initial ship is read-only databases, which is another long-standing thing people have wanted. Now, let's talk about durability for a second. Durability is another place where people want to have their cake and eat it too. When I'm operating against storage, I want those operations to be as low latency as possible. And so I want to use something like, what I really want is to not actually be storing things, to have a giant cluster of memory redundant. So everything that I want to get to is in memory, and I'm getting it at memory speeds. Or failing that, maybe SSD drive speeds. But I want everything to be super cheap. So scratch what I just said. And instead what I want is everything to be on something like S3, and which, by the way, has horrible latency. By comparison, 2-3 orders of magnitudes worse. But, hold on a second, I also want to have ACID transactions. So I need to have something that has underlying primitives that will support ACID transactions. So I want something like DynamoDB, which, by the way, is categorically more expensive than all these other things. But I also want to have, whatever AWS says, 11 nines of durability, reliability, so I'm back to something like S3. And this is another one of those sort of I want to have my cake and eat it too kind of moments. So, what do? Well, we take advantage of simplicity. Said it twice. And we know these ideas, right? This goes back, and this is cool. I want to point this out because Rich talked about these ideas this morning in the context of problems of programming. But this is going to be a moment where doing something simple turns from a programming thing to an ops thing. It's going to have operational consequences. And so we're going to make a couple of distinctions that are not always made. We're going to distinguish reads and writes. So we might actually write things over here and read them back over there from a different kind of storage. We're going to distinguish, and this is the critical one, we're going to distinguish vals from managed refs. This is exactly the same distinction that Clojure makes, right? Vals are the immutable data structures. In Datomic, those are trees, just like they are in Clojure. And then the managed ref, what's an example of a managed ref type in Clojure? An atom or an agent, right? There's one managed ref type in Datomic, it's connection, right? Connection is, in fact, a managed ref type. So it's the same concept. And we're also going to distinguish, once we're storing things in multiple places, we're going to be super careful about the words must and should, right? Because if you know you're redundantly backed up somewhere else, your semantics may be should and not must. And once you put all these three things together, you're capable of doing something that's crazy good. And that is store all data in the system in 4 places: DynamoDB, S3, EFS, and local SSDs. When you want to read it back, read it from the fastest place first, right? So read it back from the local SSD. Failing that, read it from EFS. Failing that, read it from DynamoDB or S3, depending on the kind of thing being stored. You still want the ACID semantics, so every time you need to advance a transaction pointer, you're going to touch DynamoDB. But that touch of DynamoDB now is only a pointer move. It's not the trees, it's just the pointers. What this means is that the actual load that's put on Dynamo is going to go down by an order of magnitude compared to targeting Dynamo the way Datomic targets Dynamo today. And the reliability guarantee of this is crazy good, right? Because the data is in S3 and in DynamoDB and in EFS, and the architecture supports auto repair across those. So you don't even have to trust EFS's or S3's 11 nines. You can be like, I like that, but I'd feel better if it was also over here on this machine and we can repair it. And that can all be done transparently behind the scenes. And this represents thinking about this problem off and on for almost a decade, right? The original architecture of Datomic had a really cool storage architecture that represented the first 5 years of that thinking, and this beats the pants off of it. This beats the pants off of it so much that things, you can't even create this from an existing Datomic storage representation. This has richer information in it that existing Datomic can't even capture today. And of course, you get autoscaling. So here is a picture of DynamoDB autoscaling during an import job. So at the beginning of the import job, the lines are on the floor. Then the import job happens, and every 5 minutes, DynamoDB goes, oh crap, too much is happening, and it scales up, and then the import job finishes, and DynamoDB turns it back down. For the kinds of loads that you're going to run in dev and CI and so forth, DynamoDB is going to get turned back down into the free tier anytime you're not actively pounding it, which is super cool. And then there's the production topology. So everything I've said so far is the solo topology. The production topology is all of that plus operational goodness that you want in production. In particular, everything's always clustered, so there's no single point of failure. And there's no longer any different kinds of processes. So where Datomic today has peers and transactors, this is always nodes. They're generic nodes that are managed by autoscaling groups. There's an application load balancer for HA. So again, the HA story is integrated with AWS's HA. You can go and look at the load balancer, see what it's doing. Instances respond to health checks and so forth. And there's autoscaling groups, so you can actually have a database that scales by launching new instances as load comes in. And this is, by the way, these kinds of things you could always have done for yourself, but it was enough work to set it up and enough decisions to make that people typically didn't. And this last one is sort of the icing on the cake there, which is load-specific query groups. So you can set up a group of machines dedicated to a particular job, and then the load balancer will route the queries for those machines, for that job to those machines. And so this facilitates doing something like, my primary compute resources are going to serve the web traffic, the stuff that's coming in transactionally, and then we're going to run analytics out of the same system, and we're going to stand up a query group for analytics, and those two things aren't going to compete with each other at all. Right? They're going to be completely disjoint resources. And what makes all this possible? What makes all this sort of almost easy architecturally is immutability. Right? All of this falls out of not doing place-oriented programming. Because if we were doing place-oriented programming, what would we have to do? We would have to go back and define coordination rules between all these pieces. And what are the coordination rules in this world? The same as in Clojure. There is no coordination. Everything just accumulates. There's nothing to coordinate, right? You know about things up to time 11. I know about things up to time 12. No coordination necessary. That's fine. And there's a picture of the production topology. And you'll see that it looks a lot like the solo topology, except that now there's a load balancer in front of multiple nodes in a primary group, and then there are as many additional query groups as you want. And so here I'm showing our sort of the typical use case we think of internally when we're building this, which is the transactional load goes to the primary group. There's an analytics group for heavy jobs to pull off and not put on the regular transactional system. And then there is a dev query group, and the devs don't have much of a budget, so we only let them have one machine in that group. If you have a healthier dev culture, you can have more machines in the dev cluster and fewer machines. That's totally up to you, however you want to do it. And then the production dashboard, obviously you can't read the pieces of this, but it's much more elaborate. And all of this was finely tuned around AWS pricing. All the stuff in the solo dashboard is tuned to hit that approximately $1 a day target, and everything in the production system is tuned to give you the best possible experience. So that's sort of the boundary between those two things. And then query groups, I've kind of already said this, they are additional compute resources that you can dedicate to jobs. They come and go with no disruption to primary compute. And what this does, and this is important, is it gets you out of upfront decisions. On a lot of systems, people say, well, we might have to do this, we might have to do that, we might have to do the other thing, and so we're going to make a decision in advance. We're going to put this data in bucket A, and we're going to put this data in bucket B. And then for the rest of forever, programs have to know about bucket A and bucket B. And programs that want to do something with bucket A have to go there. Programs that want to do stuff with bucket B have to go there. And you really feel bad for the programs that want to ask questions about both, right? Because they have to go to both places and then sort of seam things back up. With this architecture, you don't make those decisions in advance. You just put your data in the database, and then if you decide that there's a group of stuff called A that matters, you create a query group called A. And how does the A stuff get hot in the query group? Just by use, right? You start using it, and those machines build up a cache of the A stuff. You start using the B group, those machines build up a cache of the B stuff. And if you have some unlucky person who has to talk to A and B, they can build up a machine. They might need a bigger machine, because their cache has to be bigger. You can make a query group for them that can do both. Or you can put them on a piddly machine and just tell them, I understand what you're doing is important, but it still can take a while. So, but we're not going to hurt the caches for the other people that have the other jobs. And so then what you can do is autoscale compute. And you can autoscale compute on the traditional things. So you can autoscale compute on, you could look at CPU utilization on the boxes or memory utilization on the boxes. But there's a nicer thing that you can do, which is that Datomic keeps track of pending requests or ops that are in flight. And so you could autoscale on that. So you could say, when there's this many requests in flight, I know that that means my machines are starting to get loaded. In addition to that sort of ops in flight metric, there's also a pushback, just like with DynamoDB. Well, not just like, because Dynamo is a capacity guarantee, and this is more of a, you have whatever capacity your queries or whatever shape they are, so you don't know that. But the idea is that your system gets a message back from cloud saying, hey, you're putting too much load on this machine, come back and retry again. And just as with the AWS clients that deal with systems that work this way, the client automatically retries with an exponential backoff and eventually gives up. And you can see all of that in the metrics, and you can autoscale on it. So you can say, hey, I am super, super concerned about latency on my client, and I have a lot of money. So my rule is, if I see anybody getting pushed back even a little bit, I'm going to turn it up. Or you can say, you know what? I'd like to sort of split the difference. I'm happy to have 1 out of 100 operations get pushed back by 20 milliseconds or 50 milliseconds or 100 milliseconds. So I'll tolerate that, and I'll tune it a different way. So when? Now-ish. So this is going to be released in Q4 2017, which means that right after here I need to run out and keep working on the final polish. And query groups will not be in the initial release. So the initial release will be the solo topology and the production topology, and then query groups will follow in short order. So this is kind of what the Datomic team has been up to for the last couple of years, among other things, and we're super excited about it. And we think that it addresses sort of two big problems. One problem is that there's a ton of decisions that you have to make when you want to run on AWS, and you would like to have them made well and put these pieces together. And so it encodes those decisions and automates them, and it still leaves you in control. So it's not a service. You can go and look at the CloudFormation template. You can see how the pieces fit together. You can go in and say, hey, what would happen if I change this knob? And you can change the knob and see what happens. You might want to open a support ticket and say, what's going to happen if I change this knob before you do that? But you can, you're right, it's yours. You can put your hands on it if you want to. And if you don't want to put your hands on it, that's fine. Right? You can just use it. And it continues to deliver the full Datomic information model at a price that we believe is reasonable for hobby use and development projects and testing and CI and those kinds of places. So that's Datomic Cloud. And because I'm standing down here, I don't have any idea what time it is. So I think I'll open up for a few questions. So can somebody give me a time check? 5:50. All right, we'll do this just briefly, and then we'll break. And I will stick around during the dinner hour if people want to talk about this. I'm happy to discuss. Yes? Yes?
Anything you can tell us about the evolution of the client API and new API points that we can leverage that will be coming?
So the client API is already in Maven Central, so you can just go look at it. The only thing that's different from the client API that people are using to connect to the peer server today is the connect function is basically the only difference, right? All the semantics are the same, but the connect function is now like a multi-method under the hood, so it can be I'm connecting to peer or I'm connecting to cloud. And so the connection arguments look different, but it's essentially the same. And as part of the release process, we will be removing the alpha from the namespaces and locking in on what the model is. Yes? Not at present. Not at present. So the peer and transactor model does not exist in cloud. This is a seamless, you run it, everything is, all the processes are homogeneous model. We are eager to have conversations with people who are looking at, you know, I want some of this and some of that and some of the other thing, and we're happy to have those conversations. If you don't know this, there is and maybe Marshall can drop this into the ClojureCon Slack, there is a receptive site for feature voting for Datomic, so you can drop in there and say, you know, here's the particular thing that I'm worried about. Is there a feature that addresses this? It is certainly the case, right? Datomic Pro ain't going anywhere, right? We're now calling it on-prem to make the distinction clear of where people are likely to be deploying it. That's not going anywhere, and Datomic Pro is going to continue to be suitable for most of the people who are using it today. Our internal guess was that 90% of existing Pro users will stay on Pro, right? Partially because they're not in the cloud. That's one of the biggest reasons. You know, they're running on Oracle, they're running on something else. Partially because they're committed to an in-process application in process with their data model through peers. So there's various reasons, and that will still continue to be the case. Yes? Is this across region? So the way Marketplace works is it clones the AMI, and you can launch the AMI in any region you want, but there is not a cross-region replication capability. That's my favorite feature to work on next once we ship this, and everybody should go vote for that so I can tell Rich that you all agree, because it's super cool and we know how to do it. And by the way, cross-region replication is another example of something that gets crazy easier because everything's indelible. Right? Because you have this model that's not place-oriented programming, in order to replicate from one region to another, all we have to do is stream stuff from one place to place. We don't have to do any coordination that's like, oh my God, the thing over there changed. Right? All those kinds of problems go away. It almost feels like cheating. Right? It's so much easier to solve some of these problems that people have when they're doing things mutably. Yes?
Will there be support for database functions, schema transactions?
Will there be support for database functions and schema transactions?
Yes. Can I transact schema and add a database function?
So as of right now, we are going to have a code in the database story with cloud that is going to be, I think, different than what's in Pro. I mean, there's certainly a possibility. Right now, transaction functions are not in that code path because we would like to do something better. And just to give you a partial tease of some of the kinds of things that we think would be better, spec integration. So instead of having to do imperative or functional things, being able to do something declarative with spec. Just say, I want to be able to declare validation rules and have the database take care of it. Another thing that we think would be cool would be able to automate class path enhancement. So you specify maybe an S3 bucket that says, I want all the jars in this bucket to also be loaded on my node. And then you could call the functions in those jars inside transactions, inside queries. or whatever. So we're looking at doing something that is richer than the transaction function capability that's currently in Pro, but that probably will not be in initial ship. So that's more a little bit down the road. Yes? On the new version, are all the writes still serialized through the single transactor? This is a double pack of candy question for everybody who was in the training course. It's a great question, and I'm going to end with this question because it's interesting to explain this. So there is a potential misconception around how Datomic achieves the ACID properties. So if you look at the way Datomic Pro works, there's an active transactor and a standby transactor, and there's a protocol for how that changes. Right? The active transactor decides I'm not going to be active anymore and goes away. The standby decides I'm going to become active and start processing transactions. It turns out that everything about that handoff protocol is a performance optimization semantically. If all the processes in a Datomic Pro system thought they were the active transactor, we would still have the ACID properties. Right? Because the ACID properties are actually guaranteed by conditional writes at the data level. And so what would happen is if 10 processes thought they were the active transactor and they all wrote, one of them would win and 9 of them would fail and then die. So it's an interesting separation, another example of simplicity, right? The keeping track of who should be writing is a best effort thing. Like if you failed at it, you would still have the ACID properties, which is super cool because now in cloud, we're using consistent hashing to pick which machine processes transactions. So if you scaled up, you might have a 10-machine cluster and 20 databases in it, and consistent hashing would be saying, well, for this particular database, this one's going to apply the transactions. The other machines in the cluster forward transactions as they come in to that node, which then applies them. But again, all of that's a performance optimization. If every single thing about that is done wrong, then machines are just going to race and only one's going to win. So it's different and better in cloud, and that's one of the, so it's now no longer a notion of active versus passive. It's a consistent hash routing based system. But again, that's just admittedly, it's a critical performance optimization, right? If everybody was racing all the time to write, it wouldn't work very well as a system, but it's not required for the semantic correctness guarantees of the system that piece of it work at all. All right, thank you very much. Please come back for the unsessions tonight. I'll see you there, or I'll talk to people up here.